One of the most critical aspects of Starship's role in NASA's moon mission is its ability to refuel while in orbit. And it's incredibly exciting that we're finally getting our first real look at the hardware that will make this groundbreaking capability possible. The Starship 39 nose cone recently rolled out of the Star Factory and into Mega Bay 2, showing off new docking hardware designed for orbital refueling. These two ports look a lot like the ones featured on SpaceX's space refueling pages, and they represent a huge step forward for the future of Starship and deep space missions. SpaceX's 120-meter-tall, about 400 feet, rocket and spacecraft, known together as Starship, are designed to carry massive amounts of cargo and dozens of people into deep space. Starship runs on roughly 4,500 metric tons, 10 million pounds, of liquid methane and liquid oxygen. However, most of that fuel is spent just breaking free from Earth's strong gravity. To cover the rest of the 400,000-kilometer, quarter-million-mile journey to the Moon, Starship will need to refuel in orbit. SpaceX plans to launch several tanker versions of Starship into low Earth orbit, creating a kind of fueling depot in space. A passenger Starship would then dock with one of these tankers, top off its tanks, and continue on to the lunar surface. Blue Origin will also depend on orbital refueling for its lunar missions. As Jessica Jensen, SpaceX's Vice President of Customer Operations and Integration, once explained, propellant transfer in orbit sounds complex and scary. It seems like this big, nebulous thing. But when you really break it down into the various pieces, we've actually achieved almost all of the complex parts already on our operational programs now. And she's likely right. While in-orbit refueling has never been done before, it's a straightforward engineering challenge rather than an unsolved mystery. SpaceX has been simulating this process for years, and even the way Starship is fueled on the launch pad was designed with in-orbit refueling in mind. The system is highly efficient at both loading and removing propellant, using pressure-driven flow through its autogenous pressurization system. No pumps required. Here's how it works. Two Starships dock side by side, connecting through fueling ports. This setup has already been tested dozens of times on Earth. Next, gaseous methane and oxygen are vented through the cowbell vents, giving the pair a gentle nudge, just a few centimeters per second of acceleration. This causes the liquid propellants to settle at the bottom of the tanks, while the lighter pressurization gas collects at the top. After a few minutes, the ullage gas bubbles out, and the tanker slightly increases its internal pressure, pushing the propellant through the connection line into the mission Starship. In total, a Starship can be fully refueled in under 30 minutes, and the only thing that moves during the process is the liquid propellant itself. It's a perfect example of the SpaceX design philosophy. The best part is no part. Of course, this is bleeding-edge technology, and unexpected challenges are inevitable. That's why SpaceX plans to test this process thoroughly before it's used on crewed missions. Orbital refueling isn't just a nice-to-have. It's essential for Starship's operations beyond low Earth orbit. Without it, Starship wouldn't even be able to deliver a payload to a geosynchronous transfer orbit. So far, estimates suggest it'll take around 10 launches to deliver all the propellant needed to fill up a Starship tanker in orbit. Even if the exact number ends up being a bit higher or lower, SpaceX officials remain confident, and for good reason. While rapid refueling in space might sound intimidating, SpaceX has already shown it can handle multiple launches just hours apart with its reliable Falcon 9 rockets, which regularly send satellites and cargo into orbit. The company has even demonstrated launch pad turnaround times of just a few days, an impressive feat that will be crucial for building up the in-orbit fuel supply quickly. Elon Musk has mentioned that Starship 4 will have over 1,000 cubic meters of pressurized volume. That means a cargo version could carry significantly more propellant per flight, reducing the number of refueling launches needed in the future. SpaceX also has a strong foundation in many of the key techniques required for in-orbit refueling, such as rendezvous and docking maneuvers. Its Dragon spacecraft has successfully docked with the International Space Station more than 30 times. All that experience will help pave the way for Starship's transfer of propellant in orbit. Orbital refueling is set to undergo a series of tests starting in 2026, beginning with a dedicated demonstration mission. In this first test, 2 Starship vehicles will be launched into low Earth orbit, spaced about 3 to 4 weeks apart. Once both are in orbit, the spacecraft will rendezvous, dock, and perform a propellant transfer, marking the first real-world trial of this critical system. After the transfer is complete, the two starships will undock and re-enter Earth's atmosphere, wrapping up the test flight. These in-space refueling demonstrations will help SpaceX refine long-duration cryogenic fluid management, a key technology for sustaining a permanent lunar presence and eventually enabling crewed missions to Mars. So, orbital refueling. Very cool and very important. And it's even cooler that we're finally seeing the actual hardware for it on a Starship that's expected to fly on the next test mission. But that's not the only new feature on Ship 39. If you look through the PEZ door, you'll spot those orange components. They're brand new covers for the COPV tanks. Here's the deal. COPVs are incredibly lightweight and strong, much more so than traditional metal tanks, but they're not indestructible. If one gets dropped or hit during transport or handling, it can sustain damage. Up until now, SpaceX has protected these tanks with insulite foam, which helps but isn't always enough to guard against serious impacts. A damaged COPV would have to be replaced, an expensive and potentially risky issue, especially in spaceflight.